In this video, I'm going to show you how to use your TI-84 to come up with the p-value for a hypothesis test which involves comparing the mean of two different samples. So to find that function, you will go under the stat key and slide over to the tests submenu. Once you get there, it's just a little ways down. We are looking at the function 2samp t-test. Now, there also is a 2samp z-test. So some instructors might require you to decide between the use of each one. And 2samp z-test uses normal distributions to come up with calculations, and 2samp t-test uses the t-distribution. If you're uncertain, ask your instructor as to whether you're supposed to do that or not. But I think in more cases the t-distribution is more common. And because the functions work the same anyway, I'm only going to show you how to do this one. Okay, now there's two different ways that you can run this. Either inputting through a sets of data, or the more common way, which is to use the statistics of sets of data. So usually when you have homework problems, the statistics are provided for you, not the sets of data themselves. All right, so let's say we have a hypothetical data set here, and there's two populations being compared. The first sample we've chosen has a mean of 25.8, a standard deviation of 3.6, and a sample size of 85. And then we have another sample that's being compared, and it has a mean of 24.6. And this is just hypothetical data to run the function with, so you can see the results in the end. Then 2.1 and 63 data items. Okay, the next item asks for essentially what type of test you want to use. So that's either a two-tailed test, a left-tailed test, or a right-tailed test. And that's decided by the sign that's used in your alternative hypothesis. So that's the way it presents the question. Let's just assume we have a not equals, and therefore we would have a two-tailed test for this example. Now, the next item says pooled, yes or no. So pooling means that you're either pooling together degrees of freedom or you're not, in order to determine the correct number of degrees of freedom for your sample. Well, if you're uncertain, you might want to ask your instructor what to do here. But I think in most settings, it's probably safe just to leave this set to no and not worry about it. Okay. Then come down to calculate, press enter, and it will run the calculations for you. The first two items that it shows, we have a test statistic. We might need that as an answer. And after that is the p-value for your test, and that's probably the thing that you're looking for. Next you have DF, which stands for degrees of freedom, so that's the number of degrees of freedom it used. And then afterwards, it repeats the sample information that was provided. And the reason it does that is because if you did your calculations from lists instead of statistics, you might be interested in knowing what those statistics were. Now, if you had an example which gave you lists to work with, the way that would work is you would switch the input to data, and all you have to do is tell the calculator where you've stored your data, which would most commonly be in L1 and L2. And it's pretty uncommon in a statistics class to have frequency data along with that, so you just leave the frequencies of those lists set to 1, and that just tells the calculator each data item occurs one time only. And then the rest is the same. The calculator then knows to take those lists of data, find the mean, the standard deviation, and the sample sizes of each one, because that's what it needs in order to perform the calculations to get that test statistic and the p-value for you. So that's how it could work coming from sets of data, and that is all you need to know.